Welcome back from your break. Let's get into doing some more critical thinking as we start to think like physicists and apply our knowledge and our skills to dealing with longer questions. So let's get going. I want to remind you that in our critical thinking model, we're about collecting data, organizing that data. The most important thing that happens all the way through is to continually ask questions in terms of making meaning. And we're going to apply that specifically to mechanics. So what are the key steps and the things that you need to know about mechanics that are very important? Always identify vector quantities. You have to define the sign of direction. Make sure you draw a sketch diagram, and it could be a vector diagram as well. So even if they haven't asked you to draw it, a vector diagram, or the alternative, just to make sense of it, what we call a free body diagram. Sometimes you'll see that that's asked in questions, but I find them incredibly useful to put all the information together. So use some form of sketch to summarize the information, present it in a different way, and by doing that, sometimes you'll begin to see and understand the principle that is behind the question. Now, one of the things that I've also discovered is that when you look at a question, the information given, instead of, particularly when you're studying, instead of going straight to answer the question, ask yourself, what questions could I ask about this given information? And if you do that enough times, you'll see that there's a pattern in the types of questions that are asked. And that will help you anticipate and prepare for different types of questions. And so after you've done the sketch and the organization of information, you're going to select a formula or select a relationship and then substitute into that equation, write down the formula as it stands on the data sheet, substitute the numbers into the formula, and then solve for the missing variable. Don't try and change the subject of the formula. This is just basic algebra, but in terms of the way that physics is marked, you have to write down the formula as it's given on the data sheet. There's a mark for the correct substitution. If you change the formula and substitute into the incorrect formula, you will lose all the marks. You'll get nothing. And then final thing, remember at the end, give your answer with the correct SI unit. And if it's a vector, it must have direction with it. And that's what we mean when we say evaluate your answer. Also check if it's reasonable. So here's a type of question that you might get asked when we're dealing with vector quantities and we're dealing with mechanics. The important thing is to identify the different given information. We've got the mass, we've got that it's connected to a 10 kilogram block, that it's a frictionless pulley, and it's all shown on the diagram below. So here is the force that is applied. So that's the force applied, 25 newtons, this is what we were given, and it's quite clear. These type of problems where you have got strings and pulleys, you must get used to those. Recognize that they're not that difficult. They relate to Newton's second law. But first of all, Newton's second law. First of all, we've got to deal with the forces as vector quantities. And so as I'm going to be looking at this question, I'm going to say to myself, I've got a force at an angle here. Let me consider what the components of that angle are and try and check that the forces all add together in a free body diagram and so on. I wouldn't be surprised if that's one of the questions. And so if we look at the question, the first thing is to say, draw a free body diagram of all the forces acting on not the 10 kilogram block, but the 25 kilogram block. So it's this block. So let me identify the forces first of all. That force is the force that was applied. We recognize that there's the force of the string, and the force in the string is known as tension. We recognize there's the mass of the object, which is pulled down by the earth. So there's the force due to gravity. There's also the normal force, which we're going to write as F normal. What we're not told is that about the surface. We're told that the pulley is frictionless, but we're not really told at this point about the surface, whether it's frictionless. So we could possibly have a frictional force over here, although we have no idea that what that size is or what it is. We'd have to read more about the question, and that's always a good idea. So perhaps what we can do is we just skip on before we continue, calculate the normal force exerted, but look over here. What it tells you is that the force, it accelerates to the left, and what we recognize, the coefficient of kinetic friction is 0.15. So we mustn't forget about friction. Then there's the calculation. So if we were going to draw the free body diagram, here's the important thing. We don't draw a pretty picture of the block, we draw a dot to represent the block. Now we can start to put in the different forces. And the first force I'm going to put in is the force applied. And I'm going to label it FA. Then the next force I'm going to put in, that is there, is the force of tension, which is the string. Then I'm going to label the force downward, which is the force due to gravity. And then I'm going to label here the normal force. Now I need to be clever. I need to recognize this normal force plus the vertical component of the applied force. This one plus the normal force has to be equal to the gravitational force. So I mustn't make this one too short. I mustn't make that one too long. This red part and that need to add up to the length of that one, which I think is more or less right now. So F normal, not a very big normal force because we've got that adding in. And then the last bit, I've got the frictional force. Now, I've got to decide which direction it's going to go. And that's incredibly important because look what it says. It accelerates to the left. And so accelerates to the left. Friction always acts in the opposite direction to the motion of the object. So the frictional force will be in this direction, and we'll write it like that. Now, if we're going to take that free body diagram, and you think you're going to get full marks for it, well, you've identified all the forces, but you haven't labeled it sufficiently. What you've got to do on the side is say what each of these mean. FA is going to be the applied force, and so on. T is going to be the tension. And I'm not going to continue doing that, but I need you to understand, every time you do a free body diagram, that's what you've got to set out. You might say to me, but hold on, there's one thing that I have seen done before, and that's putting things into components. And you're absolutely right. We could take the applied force and put it into components, but then you never put in the applied force at the same time. So if you're going to convert them into components, then this is what you're going to do. You're going to need to make sure that you erase the applied force, and you're going to put in just the components. So we're going to say this component is the vertical component, V vertical, and you're going to put in this one as the V horizontal. Those are the components of the applied force. My writing isn't very neat, but I hope you can see it. You never have components and the real thing in the same diagram. Now, if we go to the actual calculation of the normal force, well, as I've indicated, that's a components question, and I'm not really going to do it, but just simply say, make sure you work out your components, because what we recognize is that there are two things that are going to add together to give you your normal. So we know VG is FG down. We know this is the component, which is vertical, and this is your V normal. And so create a vector equation, and you can do the calculation without too much difficulty. Right, calculate the acceleration of the system of blocks. Now guys, here you need to recognize that this is a typical type of question where you're applying Newton's second law, and you're going to need to solve it in terms of two simultaneous equations. So always solve it simultaneously. And what you're going to do there is to recognize the force of tension on the 10 kilogram block at the bottom has to be the same as the force of the tension on the block on the surface. You write those in terms of Newton's second law, where you're saying F net is equal to the mass times the acceleration. You break the F net down into the components that are giving you the F net, and you will have tension in both cases. You add those together by elimination, and you'll be able to work out what the acceleration is. Practice those type of equations very, very carefully. Now, this is just one long question in mechanics, but I think it covers many aspects of mechanics that you need to take note of. So please work with the mechanics and work with Newton's laws, and you will master thinking like a physicist.